Good day everyone, I am Jabo Farhana. So in this video, I will be presenting the factors that affect solubility or the nature of solute and solvent. So my objective is to observe the particular main processing, and the second one is to understand the factors affecting the solubility, and the third one is to know what is solute and solvent means. So these are the factors affecting solubility. First is temperature, polarity, pressure, molecular size. Stirring increases the speed of dissolving. Temperature. Basically, solubility increases with temperature. It is the case for most of the solvents. The situation is though different for gases. With increase of the temperature, they became less soluble in each other and in water, but more soluble in organic solvents. Polarity. In most cases, solutes dissolve in solvents that have a similar polarity. Chemists use a popular aphorism to describe this feature of solutes and solvents, like dissolves like. Nonpolar solutes do not dissolve in polar solvents and the other way around. The next one is molecular size. The larger the molecules of the solute area, the larger is their molecular weight and their size. It is more difficult it is for solvent molecules to surround bigger molecules. If all of the above mentioned factors are excluded, a general rule can be found that larger particles are generally less soluble. If the pressure and the temperature are the same, then out of the two solutes of the same polarity, the one with smaller particles is usually more soluble. Stirring increases the speed of dissolving. Stirring does not have an effect on solubility of a substance, but everyone knows that if he puts sugar in his tea and does not stir, it will not dissolve. Actually, if we left the tea to stand for a long enough time, the sugar would dissolve. Stirring only increases the speed of the process. It increases move of the solvent, what exposes solute to fresh portions of it, thus enabling solubility, as molecules in liquid substances are in constant move. The process would take place anyway, but it would take more time. So these are the materials that I'll be using. First is to set up 3 test containers, and then place 5 drops of cooking oil into each transparent bottle. Add 10 drops of water to the first container. Then add 10 drops of alcohol into the second container. And then 10 drops gasoline to the third container. After that, shake each container vigorously. Observation of cooking oil and water. Cooking oil doesn't have any polar part, and to dissolve in water, they would have to break some of water. Water will not do this, so the soil is forced to stay separate from the water. This is because oil is less dense than water and therefore it floats to the surface. Observation of cooking oil and alcohol. The polar molecules stick together, keeping the oil molecules from getting between them. They mix fine since both are made of polar molecules. Observation of cooking oil and gasoline. Gasoline effectively dissolves oil and even grease. The gas-oil mixture does not naturally separate into the natural gas and oil once it reaches the surface. Place 5 drops of Zonrox in each container. And then add 10 drops of water to the first container. And then add 10 drops of alcohol into the second container. Another 10 drops of gasoline to the third container. Observation of Zonrox and water. By mixing different amounts of bleach with water such Zonrox and water, it can make a high, intermediate, or low-level disinfectant when to be used, cleaning up a large blood or body fluid spill. Observation of Zonrox and alcohol. By mixing alcohol and Zonrox actually dissolves well, but if it was mixed, the sedative powerful enough to make you pass out or potentially die, which is the chloroform. Observation of Zonrox and gasoline. Mixing gasoline and disinfectant Zonrox doesn't actually dissolve well. It turns the fuel that it contacted with mostly inert. Place 5 drops of ink in each container. Add 10 drops of water to the first container. And then add 10 drops of alcohol into the second container. And 10 drops of gasoline to the third container. Observation of ink and water. When we put a drop of blue ink in a glass of water, then the particles of ink disperse into the water. This is because ink molecules are small in size. As a result, they occupy the spaces or gap within the water molecules. Therefore, the water also turns blue after some time. Observation of ink and alcohol. By mixing the ink with rubbing alcohol dilutes the pigment and removes its natural shine, creating a matte finish. The inks can be dropped onto the surface but can also be applied using an applicator. Observation of ink and gasoline. By mixing ink and water, it doesn't dissolve well. It was separated the color pigments. So by generalization, the maximum amount of a substance or solute that can dissolve in a given amount of another substance or solvent at a specific temperature, it is a physical property of a substance based on the chemical makeup as to whether it is polar or non-polar, and the strength of any intra- and intermolecular interaction that may inhibit dissolution. The next one that I'll be presenting is about the factors affecting solubility or the pressure. My objective is to understand the factors affecting solubility or the pressure. Factors affecting solubility or pressure. Changes in pressure have very little effect on the volume of a liquid. Liquids are relatively incompressible because any increase in pressure can only slightly reduce the distance between the closely packed molecules. If the pressure above a liquid is increased sufficiently, the liquid forms a solid. In my observation, this is due to the drink's increased carbonation. More carbon dioxide is released as the result of this. The pressure on the can's walls rises as the amount of gas in the can rises. The increasing heat raises the kinetic energy of the gas, causing the pressure to rise even higher. The can eventually bursts because it can no longer sustain the pressure. My generalization is when the pressure exerted on the substance increases, it can cause the substance to condense. Decreasing pressure can cause it to vaporize for some types of rock. Decreasing pressure can also cause them to melt.